Hey there! Welcome to hok'stutoring. We talk VC maths methods and specialist maths over here. And for today's topic, we will be discussing normal distribution, so make sure you subscribe for more goodies. In this video, I will show you what a normal distribution is, where we use normal distribution, and how do we use normal distribution to calculate probabilities. To understand how normal distribution came about, let's look at discrete probabilities first. Take, for example, we measure the height of a sample of 1,000 adults in Australia. Our data would most likely look something like this. We would expect a majority of the 1,000 people to be between 170 and 180 centimeter, and less for 160 to 170 and 180 to 190, and then even lesser for 150 to 160 and 190 to 200 centimeters. You could convert this frequency into probability by just dividing the frequency on each category by 1000 to actually give you a probability distribution. So essentially, the probability of someone having a height between 170 and 180 centimeter would be 40%, and the probability that someone has a height of less than 180 centimeter would be 70%. So 40% plus 20% plus the 10%. Of course, you may already see the flaw in this. What happens if I want to find the probability of someone less than 169 centimeters? 169 is right in between 170 and 160, but since this is not at the end of the spectrum, for each of our column values, we cannot find an answer. This is where normal distribution comes in. If the intervals of our column is too big, we simply just shorten it. So for example, instead of 170 to 180, we use column intervals of 170 to 175 centimeters. And of course, we can use smaller and smaller intervals till the columns are so tiny, we actually just get lines, heaps of them, each for their own respective height. And tada! You get your bell curve or your normal distribution curve. Two important aspects of this curve is that the curve is highest at the central location, or you could say the mean or average of the data. And also that the shape is symmetrical about the mean. Now this is where normal distribution is such an important tool for statisticians and us mathematics students. If I want to find the probability of picking a person that is less than 175 centimeter, since the normal distribution is symmetrical about the 175 centimeter, which is the mean, the probability would be 50%. There's something called the 68, 95, and 99.7% rule, which gives a baseline for finding probabilities that is 1, 2, or 3 standard deviations away from the mean. There's no better way of explaining this than looking back at our example. So based off our data, where the average height is 175 centimeter, and let's assume a spread or standard deviation of 10 centimeter, we would consider 10 centimeter to be 1 standard deviation. This is known as the standardized score, or Z, where Z equals to X minus the mean divided by the standard deviation. Therefore, the probability that a person is 165 to 185 centimeter, which in this case is 10 centimeter either side of the mean or 1 standard deviation either side, would be 68%. And if you go 2 standard deviations away, it will be 95%. And for 3 standard deviations away, it would be 99.7%. Now, to answer the main question, what is the probability of less than 169 centimeters? You would calculate the standardized score. You'll realize it is not a whole number, so we can't use our 68, 95, 99.7% rule. However, don't fear, as mathematicians in the past have already worked out those values for you already. All you have to do is chuck it inside your CAS calculator under the normal distribution commands to get your answer. And that's it about normal distribution. I really hope you found it useful for your studies, and if you did, please leave a thumbs up so that this channel will have a higher probability of staying up. See what I did there? Okay, I'm gone before this gets embarrassing. Thanks for watching.